Okay, here's the pawn, and I'm going to go over the tool paths on the lathe on how to make this. And so, going to the Cam tab, the first thing we want to do is go to Setup. Tell the machine, or tell Inventor that we're using a lathe. You can just use a generic lathe. And we want to have the axis of rotation along this axis here, so Inventor has it wrong, so we need to select that. So I can just select like here to get the z-axis. Now we're actually going to hold the part, hold the stock and let positive z be to the right here. So we'll come in from this side and lay this out, so we want to flip the z-axis. Going to the stock, the stock we'll use is a 1-inch diameter material, and so Inventor has that right. What we want to do though is I'm just going to go offset from the front and then have 0 offset, so that I'm going to face the part and then set that as Z0, and then manually we'll do that and then run the code to make the part. So now hitting OK, we can do some roughing. We're going to use a rougher to clean this, or roughing operation to go through the shape. Then we're going to have a finish pass and then cut it off. And so we're just going to go profile roughing. The tool I want to use is actually tool number 2 here. It is a different shaped profiling tool. And so if we find the lathe tools, tool number 2, notice how this has a much smaller angle here versus tool 1. And so it can fit into some of the spaces like this more easily. So I'm going to select tool number 2. This is going to be held in the 3-jaw chuck, and so I'm going to reduce the speed to a max of 2,000 RPM. And we are machining brass, and so I'm going to slow this down to 200, just half the default surface speed. And notice we have the feed per revolution at 15 thousandths. That's how far it moves in the Z each time this revolves. We'll keep that as default. The other thing I do want to do is change the step size, the maximum depth of cut. Since this is a little harder material, let's go to maybe 25 thousandths. It would still work if you kept it at the default level, but it's less material that we're taking off per pass when you reduce this depth of cut. So it does require more passes as we go through. So you can kind of see the tool going through. We do leave some material left by default. I think it left 4 thousandths in the X and Z, but we're going to now do a finish pass. And so we're going to go create derived operation, turning, profile, finishing. Same tool. I am going to reduce the surface speed, and I'm going to greatly reduce, let's go to 5 thousandths feed per revolution to get a better surface finish. You could even reduce that more, but it's going to take longer to go over that. And then let's just do a spring pass as well. Hitting that, basically we clean up what was left from the roughing operation. Final thing we want to do is just do a cutoff, and so, or a part, and so we're going to part. Inventor already knows what we want to part, but we do need to choose the tool. So tool number 3 is our parting tool. Again, I'm going to change the maximum spindle speed to 2,000. We do have a feed per revolution of 5 thousandths again, so as this moves down, it's only going to move 5 thousandths in the X for every revolution that this moves, okay, as it does its actual cutting. And I think we should just be able to hit OK. And we have this now parted off. So if we simulate, let's take a look. We can show the stock. Speed it up a little bit. We're doing the roughing. Now we're doing the finishing here, and then we part. All right, that's it.